Hi, welcome to Code Grads, and let us start with this tutorial on analyzing the performance of large language models, or LLMs, using Python. In this video, we will walk through a Python script that leverages the Grok API to interact with various LLMs, execute different analytical tasks, and visualize the results. Understanding these performance characteristics is crucial for selecting the right model and parameters for your specific applications. We'll explore token usage, the impact of temperature and top P parameters, response variability, and how models handle logical queries. Our primary goal today is to understand how different LLMs behave under various conditions. We'll be using Python with libraries such as Grok for API interaction, Pandas for data manipulation, and Matplotlib with Seaborn for generating insightful visualizations. The script is divided into 4 main analyses, each providing a unique perspective on model performance. Let's dive into the first part of our script, which focuses on comparing token usage across different models for a given prompt. Comparing model token usage. Here, we define a function compare models. This function takes a prompt, a list of models to test, and optional temperature and top P parameters. It initializes the Grok client using an API key. Then, it iterates through each model, sends the prompt, and collects the model name, its response, and the total tokens used. These results are compiled into a Pandas data frame. Next, the visualize results function takes this data frame and generates a bar plot. We then define our models and prompt. This bar plot, titled Token Usage by Model, displays the total tokens on the y-axis for each model listed on the x-axis. For our prompt, explain quantum computing in simple terms, we can observe significant differences. For instance, Qwen QWQ30 to be used approximately 1349 tokens, while Gemma to 9 be used only about 293 tokens. This highlights how model choice can impact token consumption for the same task. We then define our models and prompt. This bar plot, titled Token Usage by Model, displays the total tokens on the y-axis for each model listed on the x-axis. For our prompt, explain quantum computing in simple terms, we can observe significant differences. For instance, Qwen QWQ30 to be used approximately 1300 tokens, while Gemma to 9 be used only about 302 tokens. This highlights how model choice can impact token consumption for the same task. This heat map, average token count by temperature and top P, visualize the average token count for the LLaMA 3.370b versatile model. The y-axis represents temperature, the x-axis top P, and the cell color and annotation indicate the token count. We can see that for this model and prompt, a temperature of 1.0 and top P of 0.5 resulted in the highest token count, 566 tokens, while other combinations like temperature 0.1 and top P 1.0 yielded fewer tokens, 540 tokens. This demonstrates the influence of these sampling parameters on output length. Analyzing response variability and efficiency. After that, we analyze the consistency and efficiency of model responses. Analyze model responses function queries. Each model multiple times number of samples is 5 for the same prompt. It calculates response length number of characters and tokens per character, a measure of token efficiency. The visualize model analysis function then creates 2 box plots. The first box plot, response length distribution, shows the spread of response lengths for each model over 5 samples. We can see Qwen QWQ30 to be tends to produce longer responses with a wider range, for example, between roughly 5,600 and 7,000 characters. In contrast, Gemma to 9b provides shorter, more consistent responses, mostly between 1,000 and 1,700 characters. The second box plot, token efficiency, tokens per character, illustrates how many tokens are used per character of the response. A lower value suggests better efficiency. Most models hover around 0.1 to 0.23 tokens per character. DeepSeek R1 Distal LLaMA 70B shows a slightly lower median, around 0.19 to 0.20, indicating potentially higher token efficiency for this prompt. Evaluating logical reasoning capabilities, finally, we assess how models handle logical questions. The Analyze Logical Responses function sends to distinct logical questions to each model. It collects metrics like word count, sentence count, average word length, and a response time proxy, tokens per word. The Visualize Logical Analysis function generates a bar plot and a box plot. The bar plot, response length by model and question, shows the word count for each model, differentiated by the logical question. For the birthday probability question, DeepSeek R1 Distal LLaMA 70B and QuenQWQ32B produced significantly longer responses, around 3,300 and 3,900 words, respectively, compared to other models. The box plot, average word length by model, displays the distribution of average word lengths in the responses. Most models use words with an average length between 4 and 5 characters. DeepSeek R1 Distal LLaMA 70B show a slightly higher average word length, particularly for the more complex birthday problem. Conclusion: in summary, this script provides a comprehensive framework for evaluating LLM performance. We've seen that token usage varies significantly across models for the same prompt. Parameters like temperature and top P can alter response characteristics, including token count. Models exhibit different levels of consistency in response length and vary in token per character efficiency. Performance on logical tasks, measured by response length and word characteristics, also differs by model and question complexity. This type of analysis is invaluable for developers and researchers aiming to optimize their use of LLMs, ensuring they choose models and configurations that best suit their needs in terms of cost, verbosity, and response style.